Number 29, another stoichiometry problem, asks us to calculate when sulfur, which is in the form of 8 sulfur atoms held together, is burned in the presence of excess oxygen, that it makes sulfur dioxide. So, if this happens at 600 degrees Celsius and 1 atmosphere, we need to determine what mass of this is obtained from the reaction. So my equation will tell me my mole ratio. Every 1 mole of sulfur that burns gives me 8 moles of sulfur dioxide. But I need to figure out how many moles I'm going to end up with. So what I know at the beginning is that the volume equals 1 liter, that the pressure equals 1 atmosphere, which means that my R will be 0.0821, because that's the one that matches atmosphere for pressures, and that my temperature is going to equal 600 plus 273, 873 Kelvin. Since I'm given that PV equals nRT, it's easy to rearrange this and determine that N, the number of moles, equals PV divided by RT. So now I can just substitute in my numbers. My pressure is 1, my volume is 1, my R is 0.0821, and my temperature is 873, which means my N equals 0.040 moles. That is the number of moles of sulfur that I am burning. So now, whoops, excuse me, see a typo, 0.0140 moles. So in order to turn my moles, 0.0140 moles of S8, I use the stoichiometry. That many moles of S8 will get me 8 times as many. So there are 8 moles of SO2 for every 1 mole of S8. I need to find the grams, so I go to the periodic table and I find what's the molar mass of sulfur plus 2 times a molar mass of oxygen, and I determine that it is 64.07 grams for every 1 mole of SO2. Again, if I take a look at this, my units, moles of S8 is canceling top to bottom, moles of SO2 is canceling top to bottom. I'm left with grams, and that's what I'm supposed to find, the grams of SO2. So, multiply across the top, 0.0140 times 8 divided by 1 times 64.